Hey guys, welcome back to the channel. This is a physics buddy, and this is going to be the final session on projectile motion from derivation perspective. In today's session, we'll be going to talk about mainly equation of trajectory. We're going to see that how equation of trajectory is being calculated and how we can say that projectile motion follows parabolic path. So all these questions will be answered in this lecture, and we'll do some numericals at the end also. So make sure you write each and everything. Let's start.
So again, let me just introduce what we have done so far. So in this unit, that is unit 4, projectile and 2D kinematics, we will try to resolve the motion in two dimensions, vertical and horizontal. So here, what we are supposed to see is, suppose there is a particle and that particle got velocity at some angle theta with the horizontal. So that particle will cover displacement in vertical direction, which is supposed to be called maximum height. It will cover displacement in horizontal direction as well, which is supposed to be called range. Apart from this, we have already talked about how the velocity will change. What are the components of velocity? Initially, the particle has a certain velocity, let me say u or vi. So this velocity vi must have two components along x-axis as well as along y-axis. And the component is given by, along the theta, the component is called cos component. And along the vertical, the component is supposed to be called sine component. So whether you can use u or vi, they both means same here. So you just have to understand that the most important part here is that acceleration along x-axis is always 0, whereas acceleration along y-axis is negative of v, meters per second square, which is also called negative 9.8 meters per second square. So projectile motion can be generally of three types. Before that, there is certain assumption that we made. We already talked about that. So distance that projectile will cover is very small, so that we can consider Earth as a plane, and this is the only reason why we also take g as constant. Whereas in the upcoming unit, we will find that g do vary with certain things, like with the height, with the depth, and the g has maximum value on its surface. Like on the surface of Earth, it's supposed to have the maximum value, that is 9.8. Whereas if we move upward in the vertical direction at a certain height, which is comparable to the distance, or you can say the radius of Earth, then the g value will change. Similarly, when we move into the Earth, or you can say at a certain depth, again g value will change. So the value of g will be less than in comparison to the value of g at surface. So that is the main thing that you have to assume here while actually deriving all those things. So in order to understand how projectile motion behaves, we have to study motion under x-axis and under y-axis simultaneously. And you can say that projectile motion is nothing but it is a combination of two one-dimensional motion, that is along x-axis and along y-axis. So always remember these three things. Along y-axis, you can consider it as the motion under gravity. Whatever we have learned in 1D kinematics and motion under gravity, all the things will remain same in this particular portion. Plus, here it is simply a translatory motion where the object is supposed to move along x-axis and having these quantities with itself. So these are the three different cases of projectile motion. The first, it can be ground to ground projectile, where the project is projected vertically upward from ground and it will reach the ground after some time by covering some horizontal range and maximum height. Whereas this is another case which is also called horizontal projectile. This horizontal projectile has certain thing that the object is supposed to have velocity along horizontal direction. So you can say the particle has a velocity in x-axis, and you can call it as ux, which is also u here, and the velocity in y-axis is supposed to be 0 in that case. Similarly, this is something we call oblique projectile. The third case, oblique projectile is something we call when projectile is thrown at some angle theta, but it is going to move along the line in such a way that it will go to this elevation which is already there in that surface. So that is, these are the three things or three types of different projectile motion. So what most important here is the first and second one, and the third one, if it is there in your class, like if teacher teaches you, then we'll talk about oblique projectile. Otherwise, we have to go with these two parts only. So I already mentioned that in order to solve all those things like range, maximum height, time of flight, we have to consider the motion under x-axis and y-axis differently. So we mentioned this thing that initial velocity along x-axis is u cos theta, whereas initial velocity along y-axis is u sin theta. Whereas acceleration along x-axis is supposed to be 0, whereas acceleration along y-axis is supposed to be negative of g. Negative sign is simply representing the direction. That direction is along downward y-axis. Similarly, in x-axis, we can say the displacement, which can be represented by x, or it can be represented by horizontal range. So this horizontal range is always given for the complete motion, complete projectile, whereas if we talk about the y-axis, the displacement in y-axis is supposed to be called maximum height. But this maximum height is supposed to be for half journey, whereas for complete journey, we already talked about it, that it is going to be zero, because there is no displacement in y-axis when we are talking about the particle displacement when it is moving or it is coming back to Earth from the point of release, that is on the ground only. Similarly, at certain point, if you have to find the final velocity, that is supposed to be some cos alpha and sin alpha component. So we'll talk about it and understand the final velocities using certain examples. Now let us just try to revise all those things. But before that, a small question. A particle is projected with speed u at an angle theta with horizontal. Find the average velocity of the projectile for the period during which it crosses half the maximum height. Now this is a little tricky one. Let us try to solve it. First of all, we need to understand what is average velocity. So average velocity, we already studied that it is delta v by t. It is going to be v2 minus v1 by t. Now again, this is a vector quantity. So we are solving and finding average velocity. We have to consider all the basic principles that we learned for the vectors. So we'll be applying that only. Let's see how will it look like. So the question says you have to find the average velocity when projectile is supposed to cross half of maximum height. So let me just assume that the projectile is being thrown from the horizontal and it goes like that. So this is supposed to be the maximum height. And the question says what is the average velocity when projectile has half of maximum height like this. So
Mm.
at this particular point, this projectile must have two velocities. One is supposed to be u cos theta in this direction and one is supposed to be u sin theta in this direction. Similarly, at this point where the particle is supposed to cover half of maximum height, it again going to have two velocities. One is going to be u cos theta and another is going to be u sin theta. Now here, the thing is, if we talk about the average velocity along x-axis, it is going to be zero because we already know as there is no acceleration in x-axis, so the velocity will not change. So average velocity, when we are going to talk about it, it is going to be the same. So it is going to be u cos theta only. Whereas along y-axis, it will change. So let us just talk about it and let us try to figure it out that how we can actually find average velocity. So first of all, we'll find average velocity along x-axis. So if we just look at it, average velocity, we can find it out that it is going to be v2 minus v1, whereas v2 is the final velocity and v1 is the initial velocity over time t. So we can just assume that during that period, which is supposed to be t, the particle reaches at h max by 2 height in the vertical direction. So final velocity is supposed to be again u cos theta. Initial velocity is again u cos theta. Time is supposed to be t. So here v average along x-axis is going to be 0. Whereas if we talk about the displacement or the velocity along y-axis, now it is going to be a little tricky. See, so how can we find this Vy after this h max by 2 height? So in order to find Vy here, we have to use equations of motion. Let us see how we can do it. So from initial point or initial position to h max by 2 height, we can consider that this is the Vy. So we can use the third equation of motion. And third equation of motion says that final velocity in y-axis square minus initial velocity in y-axis, which is supposed to be u sine theta whole square. It is going to be twice of negative of g into h max by 2, like that. The 2 will cancel out this 2. So Vy is going to be g, that 2 of negative, into h max plus u square sine square theta whole under root. So this is going to be the final velocity at this point where height is supposed to be h max by 2. Now, we got to know that initial velocity is supposed to be u cos theta, whereas final velocity is supposed to be root of negative of g h max plus u square sine square theta. Again, to find average velocity, we'll apply the same formula and we'll have our average velocity like that.
Mhm.
So V average along y-axis is going to be v2 minus u1. So v2 is this. So I can say u square sine square theta minus g h max under root minus u cos theta over t. So this is going to be the average velocity along y-axis, where average velocity along x-axis is 0. Now try to remember the process. What we have done, whenever the question says find average velocity during a projectile motion along certain points, you have to find out the final velocities at that point by using equation of motion again. And those equations of motion will deal with velocity along x and y axis differently. So we have to find average velocity. In order to find average velocity, we have to find it along x axis as well as y axis differently. So just remember the concept, how we're supposed to solve this. Whenever you get the assignment from the school, we'll do some questions from that also. So it will make you understand all these things quite easily. Let's move. So we already discussed how we can calculate all those things. So first it was time of flight. So in order to find time of flight, we'll consider motion in y-axis, and that too for complete journey. So what we have given in y-axis, we have given initial velocity, which is supposed to be u sine theta. The displacement for the complete journey is going to be 0. Acceleration is going to be negative of g. And here we have to find out the time. Although we already talked about it, that how we can find it, but let's better to revise all those things. So we can use the second equation of motion to find out the equation of time of flight. So using second equation of motion, we can say Sy is going to be uyt plus half of ayt square. So Sy is going to be 0 for the compute journey. Uy is supposed to be u sine theta. Time is something that we have to find. Plus half of a is going to be negative of g into t square. So t from here we can say it is going to be 2u sine theta by g. So this is the total time which is taken by the projectile to reach the ground back. Similarly, this total time is always equals to time of ascent plus time of descent, which is always equals for any projectile. We are going to learn why it is always equal, because we don't consider any air resistance in this particular case. Air resistance is negligible, we can say, and when there is no air resistance, the time at which the time a projectile will take to go from this point to this point and from this point to come back on the ground, it is always equal. So in order to find time of ascent or time of descent, it is always going to be half of this, which is going to be u sine theta by g. So u is the initial velocity with which the particle is being thrown. So always remember, and always remember the relation, that how we are supposed to get that relation. So this is what time of flight is. Then we have maximum height. In order to have maximum height, again we are going to consider motion in y-axis, but from this point to this maximum point along the journey at A. So again we'll say consider motion along y-axis from O to A. That is half journey. So for half journey, we have initial velocity along y-axis as u sine theta. We have acceleration along y-axis, that is negative of g. And we also have time, because here the particle is going up. So the time of ascent is going to be u sine theta by g. So in order to find out h from this particular given information, we can use second equation of motion once again. The second equation of motion says it is going to be Sy, which we have to find, uyt plus half of ayt square. So Sy is h max that we have to find here, that is called maximum height. Uy is going to be u sine theta. Time, we already know it is u sine theta by g, plus half of negative of g time square, that is u square sine square theta by g square. When we solve this, we get h max as u square sine square theta by 2g. So I have just directly write the result, although you can solve it and you can get it easily. So this is the h max, which is supposed to be given by u square sine square theta by 2g. So try to remember the relation. We'll be using that relation in so many questions.
Okay.
Let's move ahead. Next is going to be horizontal range, and again we have to find the horizontal range. We have to consider the motion along x-axis. So we can say considering motion along x-axis, and we are considering full journey, or you can say complete journey, with the particle starting from point O and coming back to the ground. So this horizontal range is basically the displacement along x-axis. So here we have given initial velocity in x-axis, which is supposed to be u cos theta. We have acceleration in x-axis, which is supposed to be 0. We have time also, the total time which we found. It is going to be u2 sine theta by g. So we have only these three things given here. Now we'll again use equations of motion to find out the range. So here we can use second equation of motion once again. So using second equation of motion, S along x-axis is going to be u along x-axis into t plus half of a along x-axis into t square. This S along x-axis is going to be range, ux is going to be u cos theta, time is going to be 2u sine theta over g, and acceleration, as you know, is 0, so whole thing will become 0. So from here range is going to be, now look at the relation carefully. U into u is going to be u square. Now we are left with 2 cos theta sine theta over g. Now from trigonometry we have a relation where 2 sine theta cos theta is nothing but sine 2 theta, which can be written as this. So range has a formula which is u square sine 2 theta over g, where theta is supposed to be the angle of projection. So always remember, with whatever angle we have thrown the projectile, all the three things, that is horizontal range, maximum height, and time of flight, will depend upon that relation only. So the fourth component here that we have to deal with is equation of trajectory. So what this equation of trajectory is, first of all, we need to understand this. So equation of trajectory is basically a mathematical equation which represents the path, of the projectile. So how we can actually find out the equation? So let us simply consider the projectile once again. We can see here the projectile must go like that. Now, in order to find out that how the equation of trajectory look like this is the trajectory we have. And we have to talk about how this trajectory is actually going to look like, how we are supposed to find out the equation. Now, this is the most important part about this. What we can do is, we can consider simply a point here, and we can call it point P. As for the graph, we can call this point has a coordinate, which is supposed to be x and y. So whenever we are finding the equation of x or y in this particular case, or in any other case, so the equation of x and y is going to represent equation of trajectory. Like what exactly this x is? This x is supposed to be the distance from y-axis. So this is my x. Whereas this y, y is supposed to be the distance from x-axis, like that. So here we have considered the same things. The projectile is supposed to be thrown at an angle theta with some initial velocity u, and this projectile will have velocity component along x and y axis respectively. So here, first of all, we'll try to write what are the things we have given in this particular case. So what we are going to consider here is, from this initial point O to this point P, we are going to find out the equations. We're going to find out, or we're going to solve the motion. So we'll write what we have given along x-axis as well as what we have given along y-axis. So along x-axis, we know the initial velocity is going to be u cos theta. It will remain same. Whereas initial velocity along y-axis is going to be u sine theta. Whereas if we talk about the displacement along x-axis is x. Displacement along x-axis is going to be x for particle moving from point O to point P. Similarly, displacement along y-axis is going to be again y, because the particle has moved from point A to point P. Similarly, acceleration it is going to be 0 along x-axis, whereas acceleration along y-axis is going to be negative of g. Now, these are the three things that we are going to use to find out the equation of trajectory in this particular case. So always remember, whenever we are talking about equation of trajectory, we are actually trying to solve the motion along x and y axis in one case only. So, like what exactly equation of trajectory is? Again, this is an equation which actually represents the path of the projectile. Or you can say we try to find out the equation, and whatever that equation will represent, whatever it will represent means, like in maths also there are so many equations which actually represent the certain figures. Like for example, if we have circle, if we have ellipse, if we have hyperbola, we have parabola, everything is represented by certain equations. So here also when we are talking about projectile motion, we'll try to express that which equation it follows. So ultimately, if we are able to understand which equation it follows, so we can also talk about that which path is going to move along. So here what we're going to do is we have to find out the equation of y. So that equation of y in terms of x, that is something we call equation of trajectory. So let me just write it down here as well. So equation of trajectory is we are writing equation of y in terms of x, like that. So if we have to do this, what we are going to do now, always remember, whenever the question says find out the equation of trajectory for the given information, what we are going to do is you are going to find out time using x axis motion, and we are going to substitute the same in y axis motion. Let's see how we can do this. First, find time from x axis for O to P journey. Like from O to P only we are talking about this particular thing. So for O to P, here we can find out time using second equation of motion once again. So how will it look like? Let's see. So using second equation of motion, which is supposed to be S x is equals to u x t plus half of a x t square. Now Sx is something we call x because displacement in x-axis is x from O to P point. Again, remember what we have done here is we have considered a point P which is supposed to have some random coordinate x and y as per the graph, and we are trying to find out the x and y coordinate simultaneously. So ux is going to be u cos theta, whereas if we talk about time, so this time is something we have to find, and later on this part will become 0. So from x-axis we got time as x over u cos theta. Now this is the time we found using second equation of motion from x-axis. Now what we are going to do, we are going to find out the equation of y, that is sy, using second equation of motion once again, and we'll substitute this time, the value of this time in that equation. Let's see how it looks like. So we'll simply say now, in order to find out equation of trajectory, we consider motion along y-axis. So if we have to consider motion along y-axis, we'll use the same. Like uy is supposed to be u sine theta. For O to P journey, we already find out time, and time is going to be x over u cos theta, and displacement for that case is going to be y. So these are the three things that we'll put together in an equation, and we'll have the equation of trajectory. So we'll say once again using second equation of motion. So we're talking about second equation of motion, we can say sy is going to be uyt plus half of a y t square. Now look at the substitution carefully. So sy is going to be y, uy is going to be u sine theta, time is going to be x over u cos theta, plus half of ay is negative of g, time square, that is x square by u square cos square theta. Now we just have to simplify this equation. So y is going to be, u will cancel out u, so we are going to have x tan theta plus here we are going to have x square negative of g by 2 u square cos square theta. This is how the equation of trajectory looks like. If we just try to simplify this thing, we can write it is also equals to px plus qx square. Now, what type of equation is this? Think and tell me. Like, what does it exactly look like? What we can infer from this equation?
Y equals maybe like a quadratic.
Yeah. So this is basically a quadratic equation, and here we find out whenever we are dealing with projectile motion, we are actually dealing with a quadratic equation. And the quadratic equation generally symbolizes parabola.
Hmm.
And this parabola will give us the path. So we can say that the path of projectile is parabolic in nature. Therefore, we can say the path of projectile is parabolic in nature. So what happens here is examiner can ask you a question in which he will give you certain values and they will simply ask you to find out what is the equation of trajectory in this case. So in order to find out the equation of trajectory, either you can remember this or you can remember the process that how we came to this particular conclusion. So I will suggest you in order to remember any equation, just remember the process. If you remember the process, you can solve any question. But if you try to remember the equation, sometimes if you just missed one thing, the whole question is gone. So that is the most important part about solving the equation of trajectory. Now we have certain other forms of this equation of trajectory also. Let me just try to show you other forms of equation of trajectory. Like we'll try to see that in what other terms we can actually represent equation of trajectory. So what we have here is that y is going to be x tan theta plus x square minus g by 2 u square cos square theta minus g by 2 u square cos square theta. Tell me, what is the horizontal range we found?
Mm,
We found horizontal range as this or this. So you can
yeah.
either remember u square sine 2 theta by g. You can either remember u square 2 cos theta sine theta by g. Let us try to use this one. U square 2 cos theta sine theta by g. So u square 2 sine theta cos theta by g. Now just look at this particular range and this particular thing, which we just consider as q. So we'll try to relate these two terms and just substitute one into another. So we'll get another form of equation of trajectory, which we can directly use to solve certain questions. Like directly we can use that to just observe and solve the question.
Okay.
Let me show you how we can do that. So this range can be written as 2u square cos theta by g into sine theta. Right? Now here if you observe it is going to be cos square theta. So what we have to do is we have to simply multiply with cos theta and divide it by cos theta. So we'll get here 2u square cos square theta by g and this whole thing will become what? Tan theta. Right? So if we just
Hmm.
try to find out the value of reciprocal of this. So see g by 2u square cos square theta is going to be tan theta by r. Right?
Yeah.
We'll simply substitute this value over this equation. So we get y is going to be x tan theta plus x square. Now this is going to be negative of tan theta by r. So another form of equation of trajectory we're going to have is x minus x square by r. So this is also an equation of trajectory, but in terms of R, that is horizontal range. So I'll show you some questions where we're actually going to use this equation to find out certain things quite easily. The idea to get this equation of trajectory and solve it in different terms is basically to solve or to find different physical quantities that can be asked in projectile motion little easily. So does all these things make sense?
Yeah.
Always remember, these are the only four things in projectile motion that we need to answer in any of the question. So
All right.
let us move ahead. There are certain other things as well. Let's talk about that. So
Mm.
this is a case, a specific case. This case suggests that at certain angles, two projectile can have same range. So what this case is, at certain angles, projectile, I can say two projectiles can have same range. So that range, which is going to be same, will be same at complementary angles. What are complementary angles?
Mm. Angles that combine to make 90 degrees.
Now we can say sum of two angles when it is 90. So here are the certain cases. First, 15 and 75. So at 15 degree and 75 degree, angle might be different, but the range they're going to have is going to be same. Similarly, 15 degree and 15 degree and 75 degree once again. Similarly, 30 degree and 60 degree, they are again going to have same range like that. And here you can see one case which is represented by the red curve of 45 degree. So 45 degree is the angle at which we can have maximum range. So complementary angle case simply suggests whenever the angle of projectile for two different projectiles, sum will be same, then the range will be same. Where at certain angle, that is 45 degree, range will be maximum. So this thing can be asked sometime as to prove that how range is going to be maximum for 45 degree. So let us try to prove this thing, that how range can be maximum. So this is going to be the maximum range case.
Mhm.
So as you already know, range is nothing but u square sine 2 theta by g. So u square sine 2 theta by g suggests that the only thing which can be changed by keeping the initial velocity of the projectile constant is theta.
Mhm.
Like for example, suppose with the same initial velocity, I thrown projectile at different angles. So
Mhm.
what's the difference here? In all the cases, the range is going to be different. Why? Because the angle of projection is different. So here somewhat we understand that angle of projection is something which is responsible for the different projectiles range. So the question is, what should be the angle at which the projectile must be thrown so that it will achieve maximum range? So in order to find out the maximum range, we have to certainly make this particular form maximum. The u square by g is somewhat constant. So only sine 2 theta is something. If we just try to make it maximum, we'll have maximum range. But sine 2 theta needs to be maximum. So what is the maximum value of sine theta? Tell me. Like what is the maximum value for which sine is maximum?
Mm.
Just try to remember the graph. Like graph means just try to visualize what should be the value, maximum value of sine theta.
1.
Yeah. So if we just look at the graph, it graphs looks like that. Here this represents the maximum value 1 and the sine theta has minimum value as -1. Whereas this one is at supposed to be 90 degree. 0 is supposed to be at 180 degree. -1 is supposed to be at 270 degrees. And again 360 degree, it becomes 0. So sine 2 theta is maximum at 90 degrees. So you can say sine 2 theta is going to be maximum, which is supposed to be 1. So sine 2 theta is maximum at sine 90. So can I say 2 theta is going to be maximum at 90 degree? Theta is going to be maximum at 45 degree. So this is the case and this is the way to find out the maximum range or to prove maximum range. So here range is maximum for this particular case only. Is it clear?
Mm-hmm.
So we were actually talking about the complementary angle case. So always remember, if you have thrown projectile at two different angles such that the sum is 90 degree, the sum of both the projection is 90 degree, then both the particles or both the projectile will supposed to have same range. So here's the one question for you. Think about it and tell me what should be the answer. I'll be back in 1 minute.
Okay.
Yeah. Did you try it?
Yeah, I got 1 to 1.
Correct. You are pretty intelligent.
Like, they're like
So
basically the same.
exactly. So what you have to do is whenever you have given any two angles, just try to add those two angles. If the sum is supposed to be 90 degree, so you can say the range is going to be same. So
Mm-hmm.
as the sum of these two angle is 90 degrees, so the range is going to be same. That is R1 by R2 is going to be 1:1. That's it.
Mm-hmm.
Another question for you. Now this question covers almost everything. So if you are able to solve this question, this means that you have understood the projectile motion case completely. So question says there is a cricket ball which is thrown at a speed of 28 meters per second in direction 30 degree above the horizontal. First of all, you have to calculate the maximum height. Then you have to calculate the time taken by the ball to reach to the same level. In distance from the thrower to the point where the ball returns to the same level. So you have to find out maximum height, time of flight, and horizontal range, all of them. Just use the formula of all those three which we have derived and try to substitute the values, all the values given here. So
Okay.
u is supposed to be 28 meters per second. Theta at which we have thrown, it is supposed to be 30 degrees. Use all the relations and you have the value. Do it.
All right. Gravity equals 9.8 meters per second, right?
Yeah, take it at 9.8 only.
Okay, for maximum height, I got 10 meters.
Okay.
Yeah. Let me do atomic height. It's t equals 2u sine theta divided by g.
Yeah.
So u squared sine 2 theta by g. Sine 2 by g. Sine 6. Got about 69.3 meters for horizontal range.
Yeah, that's also correct. All right. So this is a very basic question, was by the way, but yeah, you are
Yep.
able to solve it on the first attempt. That's great.
Mhm.
There is one more question, and this is something which is supposed to be a homework. So make sure
Okay.
that you try these two questions as well. And
Alright.
in the next class, we'll see some questions from that book only, Inspire Physics, and try to solve some of those.